So I'm Dr. Oshin Anand. I lead the DS-NLP practice for Sahaj Softwares based out of North America. And I have with me my colleague, Dr. Ravindra Babu. Ravindra, you want to give a small introduction for yourself?
Hi everyone. And I head global data science team for Sahaj. And earlier I worked in multiple domains, fashion e-commerce, space research for about 2.5 decades. These are broad areas of my interests. Broadly, I can say I'm a mathematical modeling person. Machine learning is only one part of it.
Thanks, Ravindra. So I've been in the space of NLP. I have a doctorate in the same area, and I've been in the space for quite some time now. And for Sahaj, as I said, I lead the practice in North America. So I know it's a post-lunch session. We'll try to keep it a little bit interactive so that we are able to wake up after the lunch. So we have been hearing about LLMs, conversational space so far, and we know, how what the market is and how relevant it is in terms of from the market perspective, from the business point of view, how big the industry is, and we'll have some numbers on the screen that also depicts the same, right? So there's no contention about the fact that conversational AI as a space and conversational engine as a space is a relevant domain today. And you can see from this conference as well, there's been many talks around that, many booths talking about the same space. But as a matter of fact, this particular domain has gone through its own evolution cycle. So we started off with something where we started off with guided chatbots, where there were prompts and cues for the users to kind of traverse through, and then went ahead from there to an intent-based and entity-based recognition models, and then added dialogue management to it, and finally what we have today, the general purpose large language models out there powering our conversational engines as a space. If you look at conversational engine design per se, and basics, without the whole story that I was talking about just a minute ago, from a designing space, there are basically 4 steps that we need to look at. And it starts off with finding out what, given the domain, given this use case, what should be your conversation engine? What should comprise your conversation engine? What should be the design for your conversation engine? And it basically depends on 2 main factors. One, the domain and the use case that you're operating in, and whether or not you have the data, and what kind of data do you have. So you don't need to go with always the machine king or the machine gun to kill the mosquito, and smaller models might not always be a solution for you. So given the data that you're dealing with, given the domain that you're operating in, and the problem statements that you're dealing with, you have to choose what kind of conversational engine actually suits your problem statement. So generative AI might not be needed for your particular use case and might be absolutely relevant and necessary for a different use case per se. Once you have that figured out, then comes the brain and the core of any conversational engine design, which is basically your natural language processing pipeline. And this pipeline is starting away from breaking down the data that you have to designing different kinds of information, understanding information extraction that is needed to develop the models, and then to bring in the kind of dialect that you want to inculcate within your models and bring in custom intelligence as well. Things like language detection, language understanding, sentiment understanding, generation of text, system of records integration, all of that comprise the core or the brain of your conversation engine in place. Once you have that figured out, the next step is the back-end data engineering pipeline that can power the whole training, the deployment, and as well as the feedback mechanism of your model. So it's not just the model curation, model development, but also the deployment and the feedback management in place that makes a worth conversational engine for a particular domain, for a particular use case. And that's exactly what my 4th point is, which is basically you capture the conversations that's happening on the platform, utilize that, and pump it back into your brain of your conversation engine, which is basically the step 2, and keep fine-tuning that, bringing it to the level of accuracy that suits your domain and your problem statement per se. Anand, can you go to the next one?
Sure.
So if I take a minute and put a magnifying glass on this second step, which is the brain of the conversation engine, and as I talked about, it is a whole natural language processing pipeline that's going to be a combination of data processing, data pre-processing, like tokenization, vectorization, stuff like that, to the decision making on what kind of models are you going to use and inculcate, whether it comes to classification, whether it comes to information extraction, whether it comes to maybe translation, as a matter of fact. So what the choice of models that you would want to involve as part of your NLP pipeline is also crucial in terms of how good are you going to deliver your solution with respect to your use case or with respect to your domain. Once you have that in place, I mean, of course, the choice of models being one of the core aspects of it. Another aspect basically is the bring custom model that I was talking about a minute earlier. For a particular use case, probably an NLP pipeline in a conversational engine framework might have a standard classification information extraction model. But for your use case, you might need to do, let's say, probably a custom data summary. Or you probably need to do a sentiment model specific to your particular domain for your data set. Or probably you want to build a language understanding capability for a particular language that you want to operate in. So all of these custom requirements for a domain-specific model, this is where you can bring in as part of your NLP pipeline, which will become part of your brain or the core of your conversational engine space. Once you have that, there's another thing that comes into picture which we don't talk about more often, is the integration with system of records. Most of domain-specific use cases do have their own data, and they do not want the response to be as generic as possible. They want it to be relevant and domain-specific in this space. And that's where it requires understanding your own proprietary data, tying it up with your own data, as well as the data that is out there and is relevant for your particular use case. So system of records integration is also one of the key aspects of defining the whole NLP pipeline and NLP core brain that I'm talking about. And finally, we've all been hearing about the large language models in this space and how multiple solutions, multiple conversation engines can be built by integrating with these models, generic models which can answer any query, can understand context, and generate responses like humans. However, I'll slightly beg to differ here and say that we should look LLMs more smartly and should leverage them to the best capacity possible. I can give you a few examples. You don't have to build the whole conversation engine on the LLMs, but you can actually leverage the large language models to convert your unstructured data into a structured resource which can act as a system of records integration. So probably a question answer pipeline using these LLMs that can plug into your whole conversational engine framework, that can sit on a framework like IBM Watson, open source frameworks like Rasa, and can integrate and become part of the overall ecosystem. Another example is you're dealing with a domain where intent understanding and classification is very difficult. You might not have the data to train your own models. Probably you can just use your large language models just to skip up that bottleneck and then fine-tune it again as when you capture feedback in the data per se. So you leveraging LLMs doesn't have to be always in the space where you are building the overall conversation engine on top of it, but at the same time leverage it smartly and plug and play it at multiple places and leverage it in multiple senses. Another point that I would want to point out here is that when we build up domain-specific solutions, we not only want to understand context, but we also want to hold on to that context. You can actually utilize that context to build recommendative analytics on top of that, understand your customers, reach out to your customers back again and have a follow-up conversation, bring some business decisions based on the data that you have collected. And most of these models have conversational understanding just to the level of building the dialogue. Having said that, you can leverage it, but at the same time, extract the information through your own custom trained models and store that and leverage it, so on and so forth, for your recommendative analytics. So we have one example here that we built, which basically will showcase how custom model and usage of correct model for a particular domain can give you a much more free flowing solution out here. So the requirement for this use case was to be able to have a seamless conversational continuation across multiple languages. So just language understanding without breaking or without selecting the conversational flow. So if you if you see the conversation here, you started off with English. And then you get a response. And pardon me, the responses are all English because the system that was backend system from where the response is coming in is in English. But the objective here is to showcase how you can move from one language to the next without breaking the context and without forgetting the context or breaking the flow of the dialogue. So if you see you moved on from English and the user started the questioning back again in Hindi. You get a response, and then Ravindra, you can move forward. You get a response and move to the next. And then you have a query in Spanish and followed up by a query in French. Yeah, and then followed up with another language. So what I would want to highlight here is that by the usage of multilingual foundational models and fine-tuning them in language and leveraging a conversational-based framework, you can actually use that data fine-tuning to build language understanding capability in a dialogue management format where the context can flow from one language to another without the user being asked to either switch on the language or there's a detection in intermittent phase that is coming into picture, or there is a transfer happening. So what you see here is that we moved easily. The context understanding is across the whole conversation, even when you're switching from one language to another. And the user can keep on switching on the languages and as many as the model is trained on, and it will be able to understand the context and maintain it throughout the conversations. Now, some numbers to showcase, use case like these can have a business impact, and as I said, we cannot emphasize more how conversational AI has brought in business impact. For this particular use case, it was able to basically increase 12% customer reach after the deployment because there was no language barrier. So whoever you can actually go back and train and talk about in your native languages, and you can go on so on and so forth and reach as many customers in your remotest part of the world and let them interact with your systems in the native language per se. I'll take a pause here, and my colleague Ravindra would take on from here, and we'll talk about another use case in out-of-home advertising.
Yeah. Thanks, Dr. Oshin. Out of the problems that we have been working on, we chose two problems. One is conversational AI. The second one is how data science helps in customer experience in out-of-home advertising. So typically, all of us know that in typical out-of-home advertising, the life cycle starts with an intent. Some client coming to the advertising agency that you run a campaign for us for this particular purpose. So the intent, possibly it's a mail. They are saying this is a particular product. The expectation out of this campaign is possibly brand visibility. Sometimes it is sales improvement or footfall for their place. It could be any of that. The multiple expectations will be not common. They can be different. Based on that, we need to plan the entire campaign. Again, there are data science models at every customer touch point, ability to understand the initial intent to running a campaign, for example, campaign planning and campaign execution, and measuring the goodness of a campaign. These are life cycle stages. At each stage, there are multiple data science models at play. Some of them we'll discuss now. And how do you really go at each stage, next stage? So these are typical, broadly, these are some of the models that we work on, like audience segmentation. There are different, when we run an advertisement, we want to ensure that it reaches the right audience. So how do you really segment audiences, and how do we target this particular advertisement to those audiences? And similarly, the footfall control, how do we really estimate that? Again, population scaling. In general, you only have a sample of data to start with. That sample of data, we try to scale up for the bigger population. When you want to generally, when we make a decision that this ad campaign is run for these many months, and we only have a small sample based on which we measure, and make a general statement that yes, this is the kind of goodness that has brought into the client. So that is an intelligent population scaling problem. It's typically a statistical surveys, a statistical estimation problem. Then finally, the mining the visibility itself. So how does the exposure of each campaign, how does it run, and how do you really mine those patterns? Imagine you have run thousands of campaigns. Can you learn from the earlier campaigns and mine the patterns that are hidden in the massive data sets and find out that this is the best way to run a particular campaign? In this process, we work with a company called Talon. Talon has presence in UK, US, and Canada. And we have been partnering with this company. Sahaj has been partnering with the company in solving the problems. ADA is one such solution for their campaign. The ADA broadly, it targets the aggregate data instead of looking at specific user profile, because we treat this the individual user information as sacrosanct, and their privacy is preserved. And we only look at anonymized data to try to make the decisions, and probabilistically target data instead of looking at actual profiles. and measure the impact by physical footfall data. These are the broad expectations of this particular ADA model. And the data on which we depend are these anonymized historical mobile data. And these are, each individual would have given consent for his mobile to be tracked, and we don't know the person who he is, but broadly we know that he is given the consent to be tracked. Based on that, we try to understand his preferences. And that's how we target a particular campaign to a particular client. And then the audience segments from a third party. There are third parties who sell information. We marry this third party data with this anonymous historical data to bring goodness to bring a better experience, customer experience. And then finally, this out of home, another expectation is how do you really come with bouquet of frames which are both physical and digital that will bring this goodness to the client. So this itself is a very involved data exercise where you try to understand where should the physical frame be placed, and if it is highways, where it should be facing, the facing of the frame. I'll come to the next slide about the facing a little later. And also, if it is a digital frame, how frequently it has to be refreshed. And even that, you have that freedom. When it is a digital frame, you can always run multiple advertisements on the same board, and we can always, the refresh cycle itself has to be determined, again, statistically, using machine learning approaches. And the next slide, this is where, typically, this is a simple mathematical model. How do you really assess a particular ad is visible to the people? Okay, this is called exposure model. Like imagine that in the panel towards that end is facing in a particular direction. Then out of 100, what is the audience score? 100 out of 100 is the best score. Say 10 or 20 out of 100 is a bad score. So depending on where do you place this ad, and we can decide that this kind of audience score is expected. So there is a simple mathematical concepts involved in that. You can see mild dotted circles around each of the places. That is a visual region for each of those points of interest. And this is an extension of that. This again, you can see that again frames which side they are facing, and how do you really get that score. So this is again involved mathematical modeling. Most of the time are probabilistic, deterministic models. Finally, we also estimate the footfall. Once the campaign is run, when the campaign is being executed, how do you really assess that campaign is bringing goodness to the people? And during the campaign and the post-campaign, anyway, we have to measure the goodness that has brought in. These are some of the models that work on. See, what essentially so far we have covered is typical two models that Sahaj Data Science has been working. And this ADA tool itself has improved the audience uplift from 0% to a range between 15% to 45% increment. And very interesting point is most advertising agencies they target at a zip code level targeting, whereas we do it at a frame level targeting. Each frame we understand, and we see how does it really help the uplift of particular goodness of that. So and similarly, audience, understanding of audience, which audience like what kind of a product, and which product has to be executed. For example, there is a low-cost meal product for a particular company to a very expensive car that is done. So audience segments are different. How do you understand the segments? How do you target those segments to able to get that? Beyond that, data science team at Sahaj, we also have work beyond these. These are only one problem that what we discussed in out of home advertising. Beyond this, we have many more models within this itself, like segmentation, clustering of groups, mining of patterns. And outside this, we have models in computer vision, video summarization, video game analytics, and then in OCR, self-supervised learning in anomaly detection, large language models, as Dr. Oshin has covered. These are some of the areas we have been working on, and we are always excited to look at unseen problem and how do we solve that. We are open to questions if you have any of the topics that we both discussed, and beyond that also if you have any.
So we are also available at booth 409, and we are also, both of us are around. If you have any questions, if you have any interesting interactions to connect with us, we are absolutely open and approachable.
Thank you, sir. Thank you.